All right, our objectives. Make lists, use the items in those lists, use some methods to manipulate lists, like appending things to the end, or inserting them into the beginning, or deleting items from the list. Because if you have a list, you want to be able to do all that stuff. Perform a traversal. Traversal just means stepping through the list. I give you a list. You probably start reading it from the top and go down it. Well, traversal is our fancy term for that. Just means using a for loop, most likely, to go through it. And define simple functions that expect parameters and return values. See, the first question in MindTap over this chapter is a killer if you do it the way that they're trying to do it. And it's extremely simple if instead you import the statistics library, which is not how they wanted you to do it. I'm going to stop ranting about MindTap, but anyways. So what is a list? It manipulates a sequence of values, a sequence of numbers, a sequence of strings. It could be a sequence of anything that Python can hold. I don't remember if we've done any turtle drawings in here, but it could be a sequence of turtles. It could be a sequence of files. And a dictionary organizes data values by associating them. Now that's kind of an abstract phrase, and we can make it a little bit clearer, right? If you have a dictionary and it's a Spanish to English dictionary, right? Now I don't speak Spanish. It's been 40 years since junior high for me. But words like, you know, is it roja for red?
Rojo.
Rojo? Okay. Yeah. And see, that's red. And what's another word? Uno. Right? That's one.
Toro is bull.
Yeah.
T-R-O.
I may have missed. Oh, is it Toro? Like that, T-O-R-O? Anyways, okay. You get the idea, right? A dictionary is just a connection between one thing and another. In Python terms, that's called a key, and that's called a value. And so you can look something up by its key. And say we were going to look up the word muerte, which I think means death. Now, death is pretty grim. It's not in our dictionary. So when we tried to access that, we'd either get an error, or at least we'd get some function that would return false, saying that it wasn't in there, because there's no value associated for that key. Right? But if we tried to look up uno, we'd get one out of the dictionary. And if we tried to look up rojo, we'd get red out of the dictionary. So if I was going to say what a dictionary was, in my words other than theirs, I'd say is a set of keys paired with values. And each key can only be paired with one value. Not like our dictionary, where you can look up, you know, the word shop, and you can find out that it's both a noun and a verb, and, you know, it has all these different meanings. It's a one-to-one relationship. It doesn't mean that you can't use the same value, right? I don't know what the French word for red is, so I'm going to just say it's les red. That's stupid, but you get it. There. All right. So, like, you could have multiple keys pointing to the same value, but you can't have the same key pointing to multiple values. That's what a dictionary is. Whereas a list is a sequence of values. If you took fundamentals, they called them arrays. But they're not arrays because in programming languages that support arrays, an array is fixed in length. Once you create an array and it's 10 long, tough. You can't make it 11. You can't delete things from the middle of it. Whereas lists are cooler. You can append things, you can make them grow, you can make them shrink, you can do all sorts of things. So the guy who invented Python, he finally stepped down from leadership of Python over some silly, well, I thought it was silly, over some new feature in the newest version of Python. He got outvoted by other people, and so he left the group. I don't know why. Maybe he'll come back. So anyways, fundamentals call them arrays. It's just a series of values. So, like, you know, my phone number, Jenny's phone number, 8,7,85309, right. I know I've just messed that up. 75309. All right, right? So an array is a sequence of values like that. There's also something called an unordered sequence of values, which is called a set. Right? Like if you take all your fruit and you throw it into a bag, and you don't know where the apples are versus the oranges versus the peaches, that's a set. Whereas if you line them all up on the conveyor belt, that's a list. This chapter doesn't talk about sets, so we don't need to remember that. So a list is a sequence of values. We can get a little bit more complicated and say a list is a sequence of values where each value is referenced by its index/subscript. And you'll hear me use those terms interchangeably. So if we create this number here, I got to do the whole thing. 8, 6, 7, 5, 3, 9. So if I want to print out this number, I would just print parentheses num subscript 0. Right? That's the subscript. That's the index. That would print out 8. If I change that to a 1, it's going to print out 6. If I change that to a 2, it's going to print out 7. Now Python does something that no other language I've ever seen does, which is pretty cool, which is if you make the subscript negative, it starts counting the other way. So that's -1, and that's index for subscript -2, -3, and so on. I bet this is feeling kind of like review, and that's goodness. So a list allows a programmer to manipulate a sequence of data. A dictionary organizes data by association rather than position. You don't know inside the dictionary what order these words are stored in. Yeah, in one of our human dictionaries, they're in alphabetical order, but in a computer dictionary, we don't know that they're going to be stored in alphabetical order. All we know is that if we ask it for a specific key, it's going to return a specific value. So a list is a sequence of values, a shopping list, a to-do list, the roster for the Oakland Raiders. Are the Raiders still in Oakland?
No, they're about to be in Las Vegas now.
Okay.
Yeah, they're going to Vegas. Oh, that's true.
Yeah, I get lost. The guest list for a wedding, the recipe with a list of instructions, a text document, which is a list of lines, and names in a phone book. Those are all lists, right? Sequence of numbers, sequence of grades, sequence of salaries. So that's a list. Normally you would declare a list and then give it assign it to a variable, right? Normally you'd say something like fruit equals, but you don't gotta. And here's a list that contains lists inside it, which is a little bit weird, but it kind of makes sense. Like if you have a recipe and it says beat the eggs as step 3, and you don't know how to beat eggs, then maybe there's another recipe that tells you how to beat the eggs. And so that's a recipe that's got another recipe embedded in it. Or you're going to make the frosting that goes on top of the cake, and so that's its own separate recipe. And so your main recipe has sub-recipes in it. Well, this list has sub-lists in it. And I'm not really planning on talking much about that functionality. I've had books that went crazy thinking that was the most important thing in the world. We don't teach that book. When an element is an expression, its value is included in the list. So here the list is equal to x, and the second item in the list is equal to the square root of x. So if we print it out, we'd see that 2 comma and then the square root of x, which just happens to be that long number. So a list of integers can be built using a range. Go to idle, L equals, L equals list parentheses range parentheses 10 comma 101 comma 5 in parentheses, and then when I print the list, it's going to be 10, 15, 20, 25, and so on. So we use the range statement to produce a sequence of numbers, and we use the list function to convert it into an actual list that we could store in a variable. Now, why would you want to do that? Well, I don't know. But then you could write a for statement that stepped through that, right? So for value in L colon, print value times 2. It's going to take every number in this L list and print out its double. So it's going to print out 20, 30, 40, 50, and so on. Like that. So we're going to see this syntax an awful lot because that's how you step through, that's how you traverse, according to their term. Other books use the term iterate. How you step through the list with a for loop. The key word is for, and then you have a variable name. The variable name isn't important as long as you remember what it is. So just like if I come down here, I can make another variable name for blah, blah, blah in the list, colon, print out blah, blah, blah times 2. It's going to print the same thing. Right. Variable names only mean stuff to us, not to the computer. So I chose value because that makes sense to me for every value in the list. Print it out. I could have called it a number because it's a number. I could use a single letter like I or X or whatever. So len will return the length of the list. If you want to compare two lists, you can use equal equal. If you want to add two lists together, you can use the plus sign. Let's see if that works. Let's all do that. So I'm going to open up idle. Looks like we're on lecture LMNO. So new file, save as lecture O. I may have typed 0 there, but it doesn't matter. And I did my dummy mistake that I always say not to do, which is I saved it straight into the Python directory.
Is it O or N? I don't remember doing that.
O is correct, gang?
It's a O.
All right. Okay, cool. All right, so this is lecture O, which is a chapter 5. What am I doing? These are list examples. So capital L, just because I like using capital L for a list, but again, variable names don't matter, is equal to 4, 0, 5. First 3 digits of my area code. And then let's add something to it. L equals L plus, and let's add some more numbers to it. 8, 2, 8. Let's say that my phone number is 405-828. And then let's add the last 4 digits to it. L is equal to L plus, so it's 828, 1, 2, 3, 4. And then let's print out our phone number. And there's our list. So just like strings, when you use a plus sign to hook strings up, strings and lists are so similar. So many things that you do with strings you can do with lists. Like you can get the length of the list. So print parentheses, len parentheses, L in parentheses. That's going to print out 10. Because there's 10 numbers, 10 digits in my list. What if you want to add one number to a list? 2 ways to do that. And there's actually a more common way than what I'm just about to do. Now, you know that you can use plus equals when you want to add something to something. We could have done plus equals up here. Instead of L equals L plus, we could have just done L plus equals. But let's say that my extension is 5. That'll tack a 5 on to my list. But more commonly, you'll see people use the, and I always forget whether it's l.add or l.append. I'm going to try add first. Somebody remember? Somebody remembers lists and arrays? Is it? All right. And so I'm going to add a 100 to our list. Let's see if I got the syntax right. Nope, has no attribute, add. I always get them swapped because in another language I use it as add. Append. This is the more common way of doing it. What if you want to insert something in the beginning of the list? Let's say that we have to dial a 9 to access the outer. L.insert into position 0 the digit 9 or 900. We have to dial 900 to get out of our. And let's print our list now, see what it looks like. I'm hoping to see it say 900, comma 4, comma 0, comma 5, whatever, whatever, comma 5, comma 100, because we've appended a 5 and a 100 to it, so we should see those things at the end, and we've inserted into position 0 a 900. And that's what I'm saying. 900 got inserted into position 0. What if I change that 0 to something else, like 2? Well, it's not going to be at the beginning anymore. It's going to be at position 2. Well, if that's position 0 and that's position 1, it means it's going to come before the 5. So if I change that to a 2, I'm going to see 4, comma 0, comma 900, because this is going to become the new item at subscript 2. Subscript 0, subscript 1, subscript 2. I'm going to change that back to a 0, though, just for the purpose of my notes. Insert into beginning of list. If you want to check to see if two lists are equal, you can use equal equal. I don't see much of a reason to even demonstrate that. So, you know, if L equals L2, we don't even have a second list defined, so that'd be a syntax error, but you get the idea, right? If those lists had the same contents. So to print the contents of a list, you can just use print, followed by the variable name, and it'll spit it out in its raw format, separated by the commas. Usually you don't want to do that. Usually you want to do something a little bit more complicated with the data. Like we could set up a for loop to print it out. For value in capital L colon, print, I don't know, a number, end quote, comma, value. Just to show that we're doing something with it. You know, that part's not important. It's just showing that we're printing out a value. And there's all the values that are in our list. So sure, it's great to be able to print the list variable, but usually a user's not going to want to see raw data like that. They're going to want you to be stepping through it or printing a report or adding them up to calculate a sum or something like that. That's one way of printing them. The other is to do it by its index. This is a value-based for loop. The textbook may call it a little bit different. Value-based for loop. And this is going to be a subscript-based for loop.
Is that a pound in front of value?
Yeah, but it doesn't matter what it is. It's just to show that something is happening. Yeah. So for, and what am I subscript going to be called? Why not I? In range, parentheses, len, parentheses L. I'm going to start off at 0 and go up to but not including the length. Why do I say up to but not including? Because if the list is 4 elements long, I want 0, 1, 2, 3. And so then I'm going to print out maybe a couple exclamation marks, comma, and then capital L subscript I in subscript. I forgot something. I forgot the end quote before the comma. There. You can see those two things do pretty much the exact same thing, but one has a cleaner syntax, in my opinion. If you like accessing lists by their subscript, like that, you don't have to use this kind of loop. If you like doing it this way, like I do, you don't have to use this kind of loop. Most of the time, I'm going to do it this way. I think the syntax is cleaner. So this is a value-based for loop. I may slip up and call it a for each loop, because that's what other languages call it. So, like for each value in list, print that value out. And this is a subscript-based or index-based for loop. Or index-based. Those terms are synonymous. Maybe a page more. Have we not done some homework based on the idea of lists already?
Oh my God.
Sounds familiar, but yeah, we did it.
All right, so a list is mutable, meaning that elements can be changed. That 900 is totally wrong. We don't want that 900 at the beginning of it. It was supposed to be 500. So list subscript 0 is equal to 500. And now when we print it out, we're going to see that it no longer is 900, comma, whatever, whatever. It's 500, whatever. That's different from strings. Unless you're programming in C++, strings are immutable, meaning that you can't change the elements in them. So if I tried to do this, something like this with a string, and I wanted to change, the first letter of somebody's name, it would generate an error. You have to do something different. So we're going to say, add a comment, lists, are mutable, meaning they can be changed. Elements can be added, removed, or altered. And just a parenthetical comment. Strings are immutable. They cannot be changed. Mutated. That's the root word, right? The Hulk was mutated. Well, his genetics were mutable. You have a rock who can't be mutated. He is immutable. So, since strings are immutable, you can't add, remove, or alter elements through it, at least by their subscript. You have to call a method in order to change things in it. Okay. I'm going to toggle away for a second. Go look at our assignments. Oh yeah. Since I'm not giving them good names anymore. Rectangles, multi-line printout, if-else, bouncing ball. All right. I don't see stuff about lists, so we're going to come up with one. So, homework. Look up the number to Microsoft. Any number, I don't care. And create a list of the digits of the phone number. Use a value-based for loop to print the digits, and then use a subscript-based for loop to print the digits. Then look up the number to Google. I don't care. And concatenate that. I'm probably not spelling that. Concatenate that number to the Microsoft number. And you can do that just like we did up here, right? check the second or third line of our code up here. And then print the list any way you want. So those are the 4 steps. Or is it 5? Create a list of the digits of the phone number. Use a value-based for loop. Use a subscript-based for loop. Look up the number to Microsoft, to Google, and I don't really care what phone numbers you come up with. Make it the White House. Make it the Rose's number. Make it your own number. I don't care. Check the second or I'm not going to look at it and say, that's not Google's phone number. Check the second or third line of code to see how to do that. That's actually a parenthetical comment, and then print the list any way you want to. It's the last part. Alrighty. That making sense? We ought to be able to do that pretty much based on this example code, which of course I'll upload. We good on that? Sorry? Pardon me? Oh, yeah, sure. And how far up? Okay.